Hey everyone, and welcome back. This is a part of a video series again for predictive analytics, a course I teach. I'm Adam Gilbert. This video is going to be the first of two on an introduction to Python. So for those of you who are taking my course, this is following a notebook called X Intro to Python. I've decided not to make this notebook part of our main course because it's mostly background material and not directly relevant to the analytics work we'll be doing in the future. That being said, it's really necessary to have a good foundation in Python before we move forward. We're not going to need a ton of Python. You're not going to be experts, but this video and the follow-up one will get you up to speed to where we need to be with Python for analytics. So again, you have access to this notebook through the folder of notebooks that you downloaded at the beginning of the semester. This is an introduction to Python. So we're going to start from the ground up. Python is it's a widely used general programming language. So it's got lots of applications to anything from building websites to cybersecurity to what we're doing with predictive analytics and machine learning. What we're going to find throughout our course is that when we load up Python or load up a Jupyter notebook through Google Colab, Python comes as kind of a stripped down piece of software with basic functionality. Anytime we want to do anything advanced with Python or kind of specific with Python, we're going to load libraries with specific functionality. Some of the most common libraries you're going to see in our course are the pandas library, which is really useful for reading in and manipulating data frames. You heard a little bit about data frames in the terminology video and notebook that I posted prior to this one you looked at during the first week of our course. There's a package called NumPy or a library called NumPy, which gives us access to lots of mathematical operations and random number generation, which is useful for us. There's a package or library again called matplotlib and Seaborn. These are really useful for data visualization, which we'll see in another week or two. And then there's this really popular machine learning package called scikit-learn or sklearn, which is probably the most popular predictive modeling and machine learning library on the planet right now. It's a really excellent and streamlined modeling functionality or modeling library that we'll get a lot of mileage out of. But for now, let's look at the Python basics. So in Python, so you know at this point we're operating in Jupyter, which allows us to mix text cells. So again, here at the top of my screen, I have a text cell with some hashtags, 3 hashtags saying, hey, I don't want a chapter title or a section title, I want a subsection title. So the more hashtags you provide, the lower level header you're going to get. And again, we can format, so we can type text freely in here. Jupyter and Python will format this in a way that it thinks is reasonable. We can get out of the code cell and format it by hitting Shift and Enter. The next cell I've embedded in this notebook, so the notebook is pre-populated for the most part, is a code cell. As a reminder, you can hover between cells to add new code or text cells. You can also hit these plus code or plus text buttons up here to add a new cell below the cell you're currently highlighted on. All right, so our first code cell. I'm assigning W equals true with a capital T. True with a capital T is special in Python. It's a reserved string. It stands for a value true or false. So this is special. I'm also assigning the value 2 to X, the value 2.0 to Y. So this is kind of interesting. Why would you define 2 and 2.0 differently? If you've done some programming before or some computing, you might know why. And Z is a string called hello. I'm not asking Python to output anything in this code cell. So if I run this cell with Shift and Enter, the cell runs. I get a green check mark here indicating nothing has gone wrong, but I don't get any output. And again, that's because we didn't ask for output. In this code cell, I can ask for the type of object so what's the type of object stored in W? The type of object stored in X or Y or Z. And if you watched the Markdown introduction notebook, you know that when we run this code cell, we're only going to get one output back. And that's the output corresponding to the last line of the code cell. So the type of the object stored in Z is a string. It's just a list of characters. If we wanted to get all of these types, we would have to explicitly ask Python to print them out. So that's what I'm doing here. Printing, and I'm going to do something on purpose here. I'm going to misspell print in the last line to show you how sometimes frustrating coding can be. So I get an error here. In Python and Jupyter, the most informative part of the error message is going to be this last line. So we get a name error, name PRNT is not defined. And then if we look just above, there's going to be a list of the code lines that we tried to run, and one of them will have an arrow pointing at it. And that arrow is pointing at the line where Python had the error. And so I have an error in line 4, which is asking us to print the type of the Z variable. And we can see, oh, I misspelled print. Fix that, everything works just fine. And I get that the type of the object stored in W is this bool object. Bool stands for boolean. It's just true or false, a 1 or a 0. The type of object stored in X is an int or an integer. So 2 is an integer. It has no allocation for decimal points. So this allows Python to store the object kind of efficiently, with the caveat, though, that we have no room for decimal points in the object X. Then Y is 2.0. This is a different class. It's a float. Float just means decimals are allowed. So 2.0 allows decimal points. We essentially told Python, hey, we want you to account for the possibility of decimal values here. And then the type of the object Z we already saw was a string. We can use this cell to explore. So we could do things like ask for X plus Y maybe. We get 4.0 here. So Python, if you care about computing, Python has changed the type of object in X to a float for an instant so that it could add those two values and I get a float back. So the 4.0 here is indicating that decimals are allowed. I could add W plus W. And that's kind of interesting. I get 2, and that's because of the way Python stores booleans. And most programming languages will do this. A true is stored as a 1, a false is stored as a 0. So I'm adding 1 plus 1 here. This won't be anything that we have to worry too much with throughout our course, but it's worth pointing out. And here's some kind of interesting behavior. If I add Z plus Z, so hello plus hello, what's that going to give me? Hello, hello. So adding strings works in an interesting manner. And if I tried to add, let's say, X plus Z, so now I'm adding 2 plus hello, Python's going to complain and say, I can't add an integer and a string together. Interestingly enough, though, I could multiply an integer and a string together. If I do 5 times my string, I just get 5 copies of hello. Again, we're not going to do this, but it's interesting to point out the quirks of the language. All right, so we have an idea of how Python works with individual values. But what we're more interested in is not just one value at a time. We're interested in lots of values, big data frames, right? And so these data frames that we're dealing with are large sort of Excel spreadsheets is what we have in our mind. Again, single tab Excel spreadsheets, so like a CSV file maybe. And so maybe all of this was interesting to look at, but not really applicable to us. And so let's work up towards this idea of a data frame and think about a single column of values in a data frame, or a single row of values in a data frame. So these are like lists of items if I count across a row, or same thing, lists of items as I count down a column. So here's a list in Python. I define a list just like I would define an integer or a float or a Boolean value. Equals is the assignment operator here. Python doesn't care what you call your values. So if we called this object XYZZZ, Python doesn't care that that has no meaning to us. Python's fine. It's just Python is taking out a cardboard box, using a Sharpie and writing XYZZZ on the front of it, and then dumping in what's ever to the right-hand side of the equals sign into that box. All Python cares about is it knows what the box is called so that it can go identify the box when we ask for it, bring it back, and show us what's inside. So here's a list again. Lists are defined by square brackets, and entries in lists are separated by commas. So I have a list here with 4 entries, 1, 2, 4, and 99. And I'm storing that in the object called X. We can have complicated lists too, so X contained only integer values. Y contains a mixture of values. So Y is a list. We're defining it with these square brackets at the start and the end of the list. The first item or the first element of the list Y is a string. It's just the character A. The second element of that Y list is a Boolean. It's a true or false value. The third item is a 45. The fourth item is a 42. And the fifth item, that's interesting, is a list itself. Okay, so I can store lists in lists. This is kind of just a toy example. We're never going to have to deal with this in the data analytics work that we're doing in our class, but it's worth thinking about this structure just in terms of objects and how we can access them. In particular, subsetting is something that we'll be interested in, taking a particular columns of a data frame or particular rows of a data set and having access to this structure kind of gives us something to play around with and work towards that. I'm assigning X and I'm assigning Y. I have comments here. Again, comments start with a hashtag. And then I'm asking Python to print out the type of the object X and the type of the object Y. Both of these are lists. So Python doesn't differentiate that one list is containing just integers. It seems kind of harmless. And then the other list, Y, is this awkward thing that contains lots of different types of entries. So a couple of things to keep in mind here is that indexing in Python starts from 0. So if I want the first entry in a list, I have to ask for the entry in slot 0. The second item in the list would occupy slot 1. So this takes a little bit of getting used to. And so let's print out X and print out Y. Let's see, if we ask for X, item 1, so square brackets again become useful. They allow us to subset. I'm going to go into the list X. I'm going to ask for the item in slot 1, but remember slot 1 is actually item 2, so I should get 2 here. And if I really wanted the item in slot 1, so truly the first item in the list, then I have to ask for X, the element at position 0 in X. So again, this will take a little bit of getting used to, but we'll work on it. And if you have questions or run into errors, just ask. Okay, so we can access individual items in a list. We can also access lots of items in a list. So if I ask for X and then subset with those square brackets, the items in slot 1 through slot 4 is what the colon is asking. 1:4. What this is going to do is it's going to go to, well, here's the item in slot 1, the item in slot 2, the item in slot 3. There is no item in slot 4. And so, well, one of two things will happen. Python will either return to me 2, 4, and 99 in a list, or it's going to throw an error. And it seems like Python was fine with us saying, hey, here, stop when you get to the 4th slot in the list. Let's see if Python is still fine when we ask for the items in slots 1 through 400. It is. What's maybe more interesting is what happens if we ask Python to give us the items in slots 1 through 3. So again, here's slot 1. So I should get back a 2. Here's slot 2. I should get back a 4. And then in slot 3 is the integer 99. But Python uses right endpoint exclusive notation. So I'm not actually going to get back the item in slot 3. So what this 1:3 means is start counting at 1 and stop before you get to 3. So 1, 2, the next one is 3. I'm not going to include that. So I get the items in slot 1 and slot 2 here. Again, some quirks to the language that we need to get used to. Okay, so we've talked about individual kind of atomic elements, integers, booleans, strings, floats. We've organized elements into lists and created more complex structures. And we've talked about accessing individual elements within a list. In there, we just have to be a little bit careful and remember that Python starts indexing from 0. So that first item in your list occupies slot 0. And that Python is right endpoint exclusive, which means if I ask for the items in slots 1 through 3, I'm actually just going to get the items in slots 1 and 2. All right, so we've dealt with X, which was kind of the more friendly looking list. Let's take a look at the list Y and ask for the item in the 3rd slot of Y. Do you know what we're going to get back? So here, the item in the 0th slot or the 1st slot is A. Then the item in index 1 is true. The item in index 2 is 45. And then the item in index 3 is 22. So we should get back 22. Great. And if we ask for the item in slot 4, we had said that the last element in this list was a list, and we get back that whole list. Great. So the last item in the list, Y, is a list. We just saw that. What's going to happen if we ask for Y bracket 4 bracket 1? I think it's worth unpacking this a little bit. We know already that Y bracket 4 is going to return this 193 list. And then as soon as I write another bracket 1, I'm saying, hey, go to that 193 list and access the item in slot 1. So here's slot 0, here's slot 1. So we should get back 9. And there we are. Interesting question. What would happen if we replace the 4 here by a 3? Well, now we'd be asking Python to go and identify the item in slot 3. So here's slot 0, slot 1, slot 2, and slot 3. So Y bracket 3 would get us 22. And then now we'd be asking for the item in the 1st slot of 22. The problem is 22 doesn't have slots. It's not a list. And we get this error, int is not subscriptable. Okay, so similar to errors we've seen before, which is int is not callable, is one common error we've seen, which arises when we try to multiply, but we forget to use the asterisk. Here, I can't subscript or subset an integer. And the error we're getting is in this line where we've asked for Y3, 1. just ask for y3, then we get the 22 back. So this double subsetting or nested subsetting works for lists. You can see how you could extend this. If the list 193 had, for some reason, instead of 3, it was the list 3, 4, 20. Here's another little trick. I don't know if you can see it in the video, but I'm to the left of this square bracket. Jupyter is highlighting that square bracket in gray. It's also highlighting the corresponding opening square bracket in gray so that I can make sure that I've closed enough brackets. Okay, so now I've rerun that code cell and overwritten what's in Y. It's now this even more complicated list. And if I ask for Y4 now, I get 193420. That's the adjustment that we made. And so if I ask now for the item in slot 0, 1, 2 of that new list, I get 3420. So a question for you guys. How would we access, let's say this 3? Give you a second. Well, to access that 3, we need to go into the Y list and access its last element. So that's 0, 1, 2, 3, 4, the element in slot 4. So far, so good. Now, from that resulting list, we'd want to identify this list. That's the element in slot 0, 1, 2. And we wanted the 3. The 3 is in slot 0 of that object. And so there's a tricky subsetting example where we had to kind of tunnel into a list. Again, the goal here is not to say that we're going to be doing such things with complicated lists. What we are going to be doing is working on subsetting data frames, and knowing how to subset is important for us. Okay. All right. So a couple of other maybe useful things. We saw that we could subset a list using things like asking for y1:4. This would give us the items in slot 1, slot 2, and slot 3, but not slot 4 of the Y list. Okay. We can also kind of use a shorthand and say, well, I want everything starting from slot 1 and out to the end of the list. There, I'll get everything. And similarly, I want to start from the beginning of the list and get everything up until slot 3. But remember, Python is right endpoint exclusive, so I'm going to get the item in slot 0, slot 1, and slot 2. So 3 items back. Some quirks, again, with the language. Adding lists doesn't necessarily work in the way we'd expect. So you might expect when we add these 2 lists together, I'd get 1 + 5 is 6, 2 + 9 is 11, 4 + 10 is 14. But instead, we get 1, 2, 4, 5, 9, 10. So I've just concatenated the 2 lists, getting rid of the plus in between them, making them one large list. It's useful to sometimes sort data. So I can sort my list. So here's a new list I'm storing. So I'm adding these 2 lists. I know that this is not going to behave in the way I expect it to behave, but I'm going to get a long list. I'm going to store that in Z, and then I'm going to sort the list Z. I get the values not 1, 2, 4, 5, 9, 10, 18, 20. I get them in ascending order. So the list has been sorted. And if I wanted the list sorted in reverse order, the sorted function has this argument reverse that we can set to true. And then we'll get the list in descending order. All right, we're almost done with this first part to the Intro to Python series. I want to take a look at a new object called a dictionary, and then that's going to allow us to move to something called a data frame. After we introduce the data frame, we'll stop this video and we'll pick up with the next one. But remember, everything we're doing here is trying to build up to this idea of a data frame, a table. And if we think about tables, we can think of each row as kind of a list of values, or each column as a list of values. And in particular, what we're going to do is think of each column as a list of values. So a dictionary is kind of an extension of a list, but it's not as rigid as something like a data frame is. So here I've got a dictionary called colleges. Dictionaries open and close with curly brackets. And dictionaries allow me to create named slots. So my first slot is named state. And that state slot contains only one item called NH. You'll notice that the assignment in a dictionary is done with a colon operator. So I've got the name or the key is assigned to the item or the values, which are listed here, so New Hampshire. Then I have a new dictionary item or a new key. It's called school. And that's assigned to a list containing different school names. And then I have a third key called accredited, and that's assigned to 10 times the list containing true. So this is kind of a nice shorthand. I didn't have to create a list with 10 copies of the word true. From what we saw earlier by multiplying hello by 5 or hello by 2 or multiplying a list by 2, we saw that we just get copies of that list or that list element. So here what I'm getting is a list containing 10 copies of true. If we print out the colleges object, we have this. So state is assigned to New Hampshire, school is assigned to this list of schools, and then accredited is assigned to 10 copies of true. So we can think of this, oops, where'd everything go? So we can think of this, sorry, I've hidden everything on myself. So we can think of this dictionary. Sorry, let's get back to it. As kind of a list of lists. It's a less structured object. This really just is an intermediate step that allows us to get closer to data frames. So let's talk about data frames just briefly. We're going to convert our dictionary into a data frame, and we'll see the object that we're going to be dealing with from here on out in our semester. So not necessarily this college's data set, but data frames in general. Okay, so in order to deal with data frames in Python, we need this library or module called pandas. I'm going to import it with a shortened name or an alias. So when I refer to functionality in the library, I don't have to type pandas all the time. I can just type PD when I want to reference those. Now I'm going to take my college's dictionary and I'm going to feed it to this function pd.dataframe. This is going to convert my dictionary into a data frame. And then I'm going to print out the data frame. I don't need the print function here because I'm only asking for one item to be printed out, and it's the last line of my code cell. And so here's our data frame. So pandas repeated the state over and over and over again to match the lengths of the other columns. The other columns already were of length 10, so nothing, no funny business happened with those. One thing before we close here, what would happen if we changed the state entry in the dictionary from just New Hampshire to a list containing New Hampshire and Vermont? Let's go back and try it. So New Hampshire and Vermont, I had to wrap these up in the square brackets to identify that we're defining a list. And now we get an error saying all of the arrays must be of the same length. So this pd.dataframe functionality will just repeat a value in a dictionary if that dictionary key only contains one single item. But if it contains more than one, pandas will complain to you and say, hey, not everything was of the same length. So this is the restriction with data frames, is that all of your columns have to be the same length as one another. The reason for that is because if we're working with a data frame, we're saying, okay, all of the rows in my data frame are observations, and each observation should have a value recorded for each variable in my data frame. So data frames are much more rigid, much more structured. All right, so let's leave that here. I'm just gonna get back to having only New Hampshire so that we don't have an error in our notebook. Rerunning the data frame. And so now we're left with a data frame, which again is just a structure containing rows and columns. It's like a single tab Excel spreadsheet. Hopefully you found this interesting and helpful. We're going to move forward. So I'll close out this video and start a new one where we'll work with data frames and actually subsetting data frames. So everything in this video is just kind of setup and background for Python, kind of getting used to the types of objects and how we interact with them. The next video is going to be really useful for the analytics work that we do moving forward. See you then.